Good afternoon, folks. So today is sort of mostly going to be script stuff. There's not a lot that we need to do sort of Unity interface wise or dragging components onto things and stuff like that. It's going to be essentially getting set up for all of the enemy things. So we made the enemy factory last time. We are going to make the spawner and sort of go through at least 2 iterations of that. So we're going to code it up first, and then we're going to add a little bit to it. And we'll make some of the enemy scripts as well. As part of the slides, I do have like a UML diagram that shows the base enemy class and a couple of child classes for our ranged enemy and our melee enemy. So we're going to work with those. We're not going to add them any game objects just yet. There should already be some prefabs in the Unity project. They shouldn't have the script already attached to them, but I may not have removed it when I was making the starter version. So we will add it to them eventually, but we need a little bit of the AI stuff as well, because we're going to have a little sort of AI script that deals with their movement. So we're going to get that stuff set up today. So there's a few scripts we're going to create. And actually, at least we sort of outlined a couple of the enemy ones last time, so we'll sort of fill some of those in with stuff. So it'll mostly be sort of coding things, but I think one of the most useful things that C# has to sort of offer us in our game is we're going to talk about today. So we'll sort of get to that once we have the most of the scripts sort of written. We'll run into a potential problem. And I'm going to show you a way that we can fix that problem without coupling our code too much, without having those little tendrils of the spawn manager or the game manager sort of interacting with every little piece of our code. So it's more of this, so sort of the end stuff that we do today is more of this decoupling of the code, or finding ways so we don't have to have every script reference every other script, for instance. So I want to start with the spawn manager. I have a bunch of variables here. We'll use these eventually. There's sort of an empty start and update for the moment, and a couple of other functions, things like get enemies and remove enemies. So we're going to talk about this as I go in and do some coding on it. This is sort of the outline, and then we're going to fill in a couple of these things in just a moment. So the reason why it's sort of all here in the slide is so that if you come back to it, you can go back and take a look. I have a few things in here that I don't remember specifically if we've sort of talked about in detail, so things like the serialized field. So I'll mention a few of those things as I go through and code it up. So in the Unity project, we should have essentially a guy that can move around. We messed around with this sort of factory stuff previously, so we had like iFactory and iProduct and all those things. So the one that we're going to create right now from the slide is the spawn manager. So go ahead and create that. We will attach this probably to our manager game object. It's not sort of too big a deal. We don't necessarily have to. We could create our a specific spawn manager game object or something, but we'll probably for this game I'll probably just attach it to the same object that the game manager's on. Sort of have all my managers attached to one game object. But we're not going to do that just yet. We don't necessarily need to, because we're not going to be really spawning much of anything today. Just be getting more or less set up for all of it. So the variables that I want to have here are mostly related to keeping track of when the spawn should take place and keeping track of the enemies as well. So what type of enemies we're going to be spawning, and all of the enemies that exist within our game at sort of any moment, specifically within our scene, whatever scene we're currently running in. So to that end, I'm going to create a private list variable. And this is essentially similar to the array list in Java. In fact, I just did the array list lecture for CS1 today. So it's essentially an array list, but it's just list. And these are going to be enemy objects. So it's going to be a list of enemies, and I'm just going to call it all enemies. And that's just going to be a new list, enemy, and an empty constructor call. So it's just creating a list of enemies. That's it. And the reason why I want this to be a list rather than a regular array is, of course, I don't know at any given time how many enemies I might have. So I'm going to be adding enemies to the list whenever they spawn. And whenever they're killed, I'll be removing them from this list. Because in the end, I'm going to loop through this list to have all the enemies do what they're supposed to do. So every time an enemy moves, we're going to go through this list and call move on that enemy. Now, I want to have a few other private variables as well. I might want to have something like an int for enemies per wave or something. Maybe this is some variable that changes over the course of my game. I'm going to set it to 0 at the moment, but it very possibly could be just about anything. For the number of enemies that I spawn. So, I loop through my spawner and I spawn a certain number of enemies based on my factory in our case here in a second. And then I probably I'm going to make these private too, but I will let these be accessible in the inspector. So we're going to mess with that in just a second. I want to have my references to prefabs. So I want to have my melee prefab, which we're going to make here in a second, or we're going to make, I can make it later. I think we'll make it maybe next time, maybe next week. So it's my melee enemy prefab and my ranged enemy prefab. And the reason why the spawner needs these is because of the factory that I'm creating. So I would do something like this. Let's say I could say private enemy factory, and just call it factory. And we'll go back and look at our factory script. For the constructor, I need some prefabs to send into that constructor, because remember, the factory is what's actually doing the instantiation, not the spawner. The spawner will call produce on the factory to get whatever the enemy happens to be. And then there's some sort of standard variables for doing spawn type things. So I'm going to make a public variable here so we can have access to the inspector, and we'll make it a float, and this will be time between spawns. So you can set this to whatever you want. I'm just going to put it to 0 at the moment, and we'll change it in the inspector. And then you likely need a private variable, a private float that is spawn time. So this is what we're actually keeping track of as we go through. We're going to check is spawn time either greater than or less than, depending on whether you go forward or backward, whether you count down or count up to time between spawns. Now, I made some variables private, and I do have a public one here. If you want to keep this sort of encapsulation and abstraction idea from OOP, if you want to keep that sort of as close as possible in Unity, there is a way to make private variables show up in the inspector. I haven't really done this much. I haven't really sort of mentioned it too much. I just sort of say, oh, let's make it public, and it shows up in the inspector. But that really does break some of those sort of OOP principles that you sort of learned as in sort of CS1, CS2 type class, or any other sort of OOP stuff that you've used. So if you want to still follow all of those rules and still have private variables for basically everything in your variable list, then later on say, all right, I want this variable, like say enemies per wave, I want that to show up in the inspector. You use the brackets and you say serialized field. I think I mentioned this last time, I don't remember, but it's just this, it's just serialized field. And now enemies per wave, even though it's private, does show up in the inspector. So I can do that for whichever ones I want. This, and I can do it for the other one as well, for the other prefab. So any variables you want to show up, you can do serialized field. You can also serialize classes in some situations, and this gets into some of Unity's capabilities to have scriptable objects and stuff like that. So it's not something we're going to specifically talk about, but the serialized field can be quite useful. So keep that serialized field in mind. If I was still wanting to sort of follow all of our sort of make all your variables private, I would make the time between spawns private too and use serialized field. But those are your sort of two options here for getting stuff to show up in the inspector, if that's what you want. So you don't have to do it. You can do it either way, but this is a sort of another option for us. So that's the. Actually, I can just get rid of this here. So that's the variable list. We might add something to this a little bit later on, but for now, that's what we need. We're going to have an empty start and update for now. And I want to sort of outline a couple of other functions. So we are going to have a function that's just called spawn wave. And this is where the factory stuff is going to be called. And then I'll have a couple of utility functions. So I want to have a function that allows me to get the list of enemies. The game manager is going to use this function. So it's going to return a list of enemies. And it's going to I'll just call it get enemies. So simple, just a simple getter, and it's going to return our all enemies. So nothing too complicated here. And then I want one more function. Because our spawn wave will be adding any newly spawned enemy to the list, so to our enemy list, then I want a function that will remove an enemy from the list. So this will just be enemy E. Enemy E. And it's just going to be our list, all enemies, dot remove E. So just a couple of utility functions. The remove enemy should be pretty straightforward. Just takes an enemy, removes it from the list. It's doing it on the object, so I don't need to find the index. So remember, in array lists in Java, you don't have to worry about finding the index if you have the type. You can send the type in, and it will remove it. So essentially, it's comparing sort of memory location type things and saying that, oh, is this the enemy? It is. Remove it. So we'll have a remove enemy. We have a get enemies. We'll use that later on. And then we will write our spawn wave here in just a second. I don't know what's doing here. Just let me save maybe. Yeah, let's do something weird here. Okay, so that's our outline. Yeah, I'm not sure. Yeah, Andy, I'm not sure what the problem is here. If I missed something somewhere. Don't know. Let's see if it complains up one here. Yeah, it didn't complain up here. Yeah, I'm not entirely sure. It's definitely picking something else up because I get my reference stuff here, so I don't know for sure. We'll see sort of as we go along if there's something weird happening. Yeah, that's my thought too, Nathan. Sometimes it has issues with stuff that definitely shouldn't be having issues with. Most likely, Unity will probably compile fine. It's just some weird VS Code thing probably. All right, so that was sort of this initial outline. I want to fill a couple of these things in because I want to get the factory and the spawn wave in, so that we're just sort of ready to use our factory, ready to use our spawning mechanism, and then really all we have to do is get our enemies set up, and this should be able to spawn them the way we want to. So in start, we're going to create a new enemy factory. So we're going to send in the melee prefab and the range prefab. So that was in our factory. We took in two sort of prefabs, and this is how we're going to send them in. So in start, whenever this spawn manager starts, it creates a new enemy factory. And I don't think we added this function in, but you can imagine having other functions where you need to set stuff. So maybe I have a wave counter in my factory, and I set the wave counter to 0. So it's on wave 0. After we do a spawn, maybe the factory needs to increase its wave or something. So this sort of factory.set wave isn't necessarily there because we need it to be there, or we created a set wave function. It's more or less there that we can set any variables we need to set, or change anything we need to set. Obviously, the wave could be like another argument in the constructor or something, but we'll sort of wave that under the rug or something at the moment. So let's throw in the creation of the factory and this spawn wave. So all that spawn wave does is it checks if the spawn time is less than or equal to 0. So we're going to be counting down. it will print out wave spawning, and it goes through and it spawns and number enemy per waves, or enemies per wave. And all that does is call factory.produce. And we get an enemy. Now we do have a cast here, and that's maybe not necessarily ideal. And so we'll talk about this a little bit, especially as we sort of get through a little bit more of the enemy code. And then notice that it adds the enemy that we just created to the all enemies list. So, and then after it spawns, it changes the spawn time to time between spawns. So, you know, whether that's 5 seconds or 10 seconds or whatever, it's going to change that spawn time. And then every update, it counts down time.delta time. So it's just that same sort of spawning stuff we've done before with the pipes or with the fireballs. It's just split up a little bit more, because spawn wave will end up being called from our state machine. So that's why I've split it up a little bit like this. So back here, let's just throw in spawn wave first. We want the, and yeah, we'll just keep the factory in there for, we'll write the other ones here in just a moment. So what I need to check is if the spawn time, if that's less than or equal to 0, 0f. So we're just counting down. We're going to, I don't necessarily need to create the enemy E here, but I guess did it to be a little bit more verbose. And we'll do a quick print. This is wave spawning. And then we'll do our for loop. So I'll say I equals 0, I less than is per wave, plus plus. And we'll say E is equal to a cast to enemy. Because remember, if the factory gives us back an I product, it does not give us back an enemy. That's why I need to do the cast. Now, right now, the way we're writing this code at this moment, we don't need the cast. We kind of do because we're throwing it into the array, but we wouldn't need the cast if all we were doing was just sort of spotting the enemy this way. But because we're going to be using this E to do other stuff, we're going to call some functions on E, we do need to do the cast here. So this will be factory.produce. And then we're going to take our all enemies dot add. And then after the for loop, after we're done spawning everything, I don't know why. I might close VS Code and reopen it again. It is acting a little strange. We take our spawn time, and I set that equal to time between spawns. So simple spawning behavior. The point is it's creating however many enemies per wave. And this is something you might get from, this is something you might compute somewhere in this class. Is something you might tell the factory. You might get it. You might get the number of the wave, the current wave we're on from the factory, and then compute enemies per wave. There's any number of ways that you could potentially get this enemies per wave value. But the point is we're spawning potentially multiple enemies and adding them all to the list. That's the big thing, so that we're keeping track of the list of all the enemies that are currently spawned, because we'll need that for doing movement and all that other kind of stuff. In start, this is where we're going to actually assign our factory. So this is a new enemy factory. And we're going to send in the melee enemy prefab and the ranged enemy prefab. So we'll send those in, and then anything else, any other stuff that the factory needs set. So whatever other stuff is useful. Yeah, I'm actually going to close this out, and I'm going to regenerate the project files for this just to see if something weird's going on here with this. probably have misspelling in there too. Those, and we'll see. Yeah, for the ranged enemy prefab, I did misspell the one up here, so I do want that to be ranged enemy prefab. And we'll see when this gets all loaded up. The last bit is in update, so that's just going to be where we would decrease the spawn time. So spawn time minus equals time dot delta time. This guy, let's see. Let's keep on misspelling this. I don't think so, but I'll try it again. Or it's more VS Code being weird and prefab here. So it does take the 2. So the enemy factory constructor does take the 2. So there shouldn't be any problem here. Potentially, I need to update either the integration in Unity or potentially VS Code itself, because it's definitely giving some problems here. Because systems.collections.generic, that's what contains list. So list should work fine. So it is kind of strange that it's having some problems here. Add is capital A, however. It should be capital A. Yes. And then we'll add E to that. There we go. So that should be better. Okay. So yes. So add capital E. That's an easy one to forget, especially when I just came from array lists in Java. Okay. The spawn manager, again, is not too complicated. We are going to add to this. There's a few extra things that we need to do here. So right after we do the spawn, we're going to set something in the enemy. So the enemy, for example, needs to know what is its target. What is it going to be shooting at? What is it going to be moving towards? So that's something that we're going to be adding. And we're going to be doing something else that's going to help us remove the enemy when it dies. So when we get to that point, when we get to a potential issue in our code, then we will sort of deal with that. We'll deal with removing the enemy that has died because the player shot it or something. We'll deal with removing that from our list itself. Okay, so for now, this is what our spawn manager looks like. And there's a few pop-ups in here that just sort of mention a couple of the individual pieces here. All right, so the enemy is going to look like this. So I'm going to grab my annotation here. Enemies implement iProduct. So we've already coded up just the very sort of bare bones of the enemy class, which is just literally enemy that's a mono behavior and an iProduct, and then 2 concrete classes that have nothing in them. So we're going to fill some of those things in right now. So the big thing is that enemy extends both mono behavior and iProduct. So it's sort of the Java terminology, it extends mono behavior because it's a child, and it implements iProduct. So we sort of already have that sort of ready to go. Most of the data in this section here is just related to things like health and rigid bodies and the target and the movement speed, stuff, the standard sort of parameters that you would expect a game object or a game entity to have. But there are a couple of things in here that I do want to talk a little bit more about. And then I have awake and set target. These are concrete that are not going to be overloaded. So these are not going to be overloaded. The rest of them, these are virtual. These are the virtual methods. These are the ones that will have an implementation in the enemy base class that note is abstract. They will have implementations, but they will be virtual, so you can override them. So remember in C#, a virtual method, when you use the virtual keyword, it allows it to be overridden in a child class. Whereas if you don't put the virtual keyword in, you can't override it. This is different from Java, of course. Java, you don't have to do this sort of extra keyword stuff, but in C# you do. So we'll make a bunch of virtual methods, things like move, get movement, get attack, take damage, because they might be doing different things. an enemy's movement or what the enemy does when it dies might be different for a ranged enemy as compared to a melee enemy. So we want these to be virtual so that in our concrete implementations, things like get attack, get movement, things like those can be overridden. Now, I didn't override everything in here, but it gives us the opportunity that if on death we want the melee enemy to do something different, we can easily override it in our class. And then we have a few things here, things like for ranged enemy, we need to know what the projectile game object is. So there's a couple of extra variables like time between attacks. The melee enemy might have sort of a sword swinging animation or something, or maybe not. Maybe if you touch it, you take damage, and that's what this does. It just chases you down. So we might need some variables like that. Some of these, because both of these enemies have them, you could probably put them up into the enemy base class, but of course that's an implementation decision. So the biggest thing and the thing we're going to start with is the variables and the virtual classes. And then a little bit later, we'll fill in the ranged and enemy, ranged and melee enemy concrete classes. So you can always come back and take a look at this to sort of see what methods and variables and stuff that we need. Now, one of the special ones here I want to talk about is this AI movement variable of type Iai Move. So it's an interface. I started with a capital I, so it is an interface. This is a component that we're going to add to the game object. So you can do the same exact thing with the factory if you wanted to. We made the factory just a regular class, not a game object, and specifically not a mono behavior. With our Iai Move type, so our interface for Iai Move, we're going to create some subtypes of that. So we're going to create some stuff that implements Iai Move. And then we're going to actually attach it to the game object. So that if you want to change how a character moves, you just replace the Iai Move script on a game object. So I'll show you how that's all going to work. I think we'll make this today. I don't think I have a slide that shows that today, but I think we'll make this today so that we can at least sort of mess around with it. It just has one. It just has one virtual method. So it's not anything. It's not anything crazy. It's just an interface. So yeah, so let's hop in. Let's create a few of these. I think we might create this first, and then we'll start creating some of these variables and sort of filling in that enemy class that we need. Yeah. So yeah, so I think I will. I think I'll make this first. This Iai Move script. So back in Unity here. Yeah, so everything compiled just fine. It was just this code's just being a bit weird. All right, so the script I'm going to make is the Iai Move, and it's just going to be an interface. That's it. It's not going to do anything else. It's going to have one method in it that we will use later on because we're going to talk about some of the AI stuff next time. So we'll start filling in some of this AI sort of movement stuff that I'm talking about. So I'm going to delete all this stuff. I don't need the mono behavior, and this is an interface. And the only thing that's going to be in here is going to be, I think we're going to return I think it's a vector 2, if I remember correctly. And this is going to be vector 2 get movement. And it's going to take a transform. Transform that I'm just going to call T, or transform in the autofill, and then a int or maybe a float called speed. So anything that is an AI movement is going to be able to get the movement of that AI by taking in a transform, which will be the target. That'll be where it's trying to move to or who it's trying to follow, and a speed at which to do that. So that's all this interface says. But in our enemy class, so I'm going to open up that. We should have enemy. That's just, all I did was say that it's a mono behavior and an I product. So this is just our very basic thing that we did last time. By doing this, by saying I have an Iai Move, I'm going to call this Iai Movement. By doing this, I can put any movement that I program, any class that implements Iai Move that has a get movement function, I can put that in here and attach that. And if I want to be really tricky, right above my enemy, I can put in a require component, type of Iai Move, which means that my enemy object, I slap this this script onto a game object. It must contain an Iai Move type, a script that implements Iai Move. So some of this will become a bit more clear once we create our actual AI movement scripts. But imagine having a script that was chase movement. So I create a new script, I call it chase. And I have it implement mono behavior, so I can attach it to a game object, and AI move. And maybe I have another one called I don't know, like some sort of like move to range. So it moves to a specific distance from the player and then starts doing stuff rather than a full chase. That's two separate scripts, and it's very easy for me to attach it to a different enemy, or to swap it out if I realize that, oh, I don't like this chase. Maybe I'll write a different AI movement script, and I just have to replace it, and it will use that AI movement instead. So what I'm doing here is making something that's going to be modular. That's the main thing that's going to happen here. We're going to have a modular AI movement system, and at the end, you'll probably be able to imagine how you could do this, make this sort of modular system with any type of component. So anything from a factory, like we did for spawning, to AI, to other types of game systems, to make them as modular as possible. For every enemy, we're also going to need, and I'm gonna throw this in here as well. We're also going to need a rigid body, and it'll probably be a rigid body 2D. So just sort of, I know we're going to need a rigid body 2D, so we may as well throw that in there. All right, let's fill in a few more of these variables. Mostly it's just standard stuff. I can make this, for example, I can make this private. I'll make sure to throw in the visibility here as well. So maybe something like private health. So that's whatever the current health of the private. We'll make this an int. Whatever the current health of the enemy happens to be. If we want to have a few of these things be public, we can. And actually, we don't want these private because we're going to have the subclasses, so we want these protected. And on the, let me go back to here to the slides. On here, any of the yellow ones, those are protected. So the red ones are privates, and anything that's green here you see is public. So public set target, the public function, kill enemy. This thing that we haven't quite talked about yet, this action thing, is going to be public. So we will throw a few of the sort of protected and public and private stuff into these classes. So we'll have a bunch of protected stuff. So I think the next one was our rigid body. So it's rigid body 2D that I'll just call rigid body. And I think we're going to have a vector 2 called move amount that we'll fill in later. That's just as it sort of sounds, that's just the amount it's going to move whenever it calls its own move function. So that's something that we fill in with the AI movement. And I'm going to make this kill enemy thing. This is a system.action. We're going to go over this very soon because it's one of the coolest things you can do in C#. Call this kill enemy. You don't have to understand it yet. going to go over it today. It is going to help us quite considerably. And after I sort of show you how this action thing works, you will most likely realize sort of other places where you can easily use this. So for now, we're just going to throw it in. Then for some of the serialized fields, so the ones that will be accessible in the inspector. So I'm going to serialize a few. We're still going to have them be protected. Actually, this is supposed to be public. Our action here is supposed to be public. Let's see. So I have it set for an int. I don't know what showed me there anyway. Oh, did we? Yes, an int will be fine for it. That was what the issue was there. Yeah, and it should be fine. I don't plan to have any fractional sort of stuff going on with the health. All right, for the first sort of serialized field, I'm going to have this be a player, and I'm just going to call this target. So all the enemies, the only thing they're going to be doing is going after the player. So I'll have a reference to a player that is just a target. This is something that will be set after the enemy spawns. So the enemy spawns, I set the target to whatever it needs to target. Now here I have it as a player, but in principle, it could be targeting something else, right? Enemies could potentially target each other, in which case you'd have to mess around with what the type of this actually needs to be. But for our game, it's fine having the sort of the target only be set for the player. And we'll do another serialized field. And we're going to have a int for max health. So when the enemy spawns, its health will be equal to its max health. So that's something we'll set in the inspector. And let me put the visibilities on here. So these are just going to be protected. And for the last one, I think it was the movement speed. So we'll just have that be an int as well. And that's something that we can set in the inspector. In principle, you're putting the enemy script onto a prefab, and then you're setting these variables on that prefab. Not necessarily the player target, but the max health and the movement speed. Those are things that we're going to set in the inspector once we've thrown this onto a game object. So we don't have to worry about what exactly they are now. That's something that we can tune and do whatever we want to with later. For now, just know that we have them, and this is what they're supposed to represent. Now, I am going to use awake here. Remember, awake happens before start. So it's just void awake. And this is where we're going to set up things like the rigid body, make sure that we get that component. This is where we're going to set up the Iai movement, make sure that we get that component, and where we set the health equal to max health. So we'll have something like this. Health equals max health. We'll set up our rigid body so that this is going to be, I think it's, I don't know why my stuff went away now all of a sudden. Yep. So we're going to get component, rigid body 2D. And for that Iai move, we're going to also get components, Iai move. So this will get the script that contains the Iai, and actually this should be Iai movement. There we go. Yes. So that Iai movement variable we have up here, I don't have to worry about setting it in the inspector or doing any of that. As long as I have a Iai move component or a script that implements Iai move on my game object, this will grab whatever script that is. So that's the power. That's what makes this modular. Now my Iai move has the appropriate movement. When this object awakens, so basically as soon as it spawns, this stuff is initially grabbed. I don't think, if I remember correctly, and this is something that we might change in the future, I don't need start or update here. so we can actually get rid of them. We could probably have put this stuff into start. It would probably be okay as well. But awake is just one of those things that it happens. It basically is calls as soon as this script is loaded up. There's a couple of other methods that I want to write right now. These are a few of the sort of public ones. I think on the let me check here. I think on so I have awake. I show awake as protected. I don't think this is 100% necessary, but we will be calling awake from the subclasses. So I am going to set it to protected, but I think it being just either no visibility or public should work fine as well. I don't think there would be any problem, but I am going to make this protected. If I spell it right. All right, let's fill a few of these other functions out. So I think I had move, so public virtual. This is one of the virtual functions. Void move. So this will be one of them. We'll fill it in just a second. And we're going to have get movement. So we'll have get movement. That'll be another one that we could override if we want to. The point of get movement will be to set move amount. That's going to be the whole point here. So essentially, for the default implementation of this, before I override it in one of the child classes, I could just say move amount equals vector2.0. So if for some reason I write an enemy class that does not override get movement, then its movement amount will always be 0. It'll stay right where it is when it spawns. So move is going to do this. Move is going to call get movement. So as soon as I call move, it's going to grab whatever movement needs to happen. This will be based on the AI, but in the base class, it's just 0 movement. And then I'll do the rigid body stuff. So I'll say rigid body dot move position, and we'll do a rigid body dot position, and forget the other ones. Multiply that by I think the move amount. No, add the move amount. Add the move amount multiplied by time dot delta time. We will move this into a fixed update later, but for now, if you call move on an enemy, it will get the movement, which will be based on the AI in the future, and then it will do a move position. So it'll go wherever it currently is, plus whatever the move amount is, times time dot delta time. So same sort of stuff we've been doing. It's just I've sort of broken it up a little bit more. ND virtual means that in a subclass, we can override it. If it doesn't have virtual, then we can't override it. So we may not override move, but we will most likely override get movement. So our get movement in our ranged enemy or in our melee enemy will depend on the AI that we give it, not just be 0. The other ones, there's like get attack and a couple others. So let's do that. So these ones will probably want to be overridden. So like virtual, for instance, virtual void get attack. This is probably going to be different depending on ranged and melee. So for now, we'll just leave this empty. But we'll most likely override it. We need take damage. And this is something where it probably should take a variable. So maybe an int called amount. And then we say health minus equals amount. And then, of course, this is where you can check for things like if health is less than or equal to 0, then we're gonna have to die. So we'll call like a death function or something that will autocomplete to something else. So we'll call it death function. We'll write that one here real quick. And this is, of course, where you'd play, you could put in a generic particle system or something that you throw in here as well, so that it plays, or instantiate a particle system and play it. Whatever you want to do when something takes damage or dies. We're going to make another virtual function called death. So I'll get that one in there, and this is where we can just do destroy. Destroy this game object. So that's the actual death, the actual destruction of the game object in our scene. So those are all the virtual functions that we're going to have. They're all relatively simple. I know I went through them a little bit quick, but get attack, we didn't do anything. Take damage is stuff that we've sort of written before. A death is sort of an easy one that just destroys the game object. Think of it as the sort of each one of these individual function is only meant to do one thing. So that's why we sort of seems like we have a lot, but like take damage just subtracts based on the value that comes in. Death destroys the game object. Get movement is just setting move amount. Move is getting the move amount and actually moving. So they all sort of are responsible for one little piece. There was one that I missed. The other one that's not virtual. This is the set target. So public void set target, and this is where we're gonna bring in a player. So whoever calls this function is going to send a player in, and the target is set to whatever player comes in. So this is something that we're going to call once we've spawned the enemy. So the enemy spawns, and we're going to call enemy.setTarget and send in, say, the player, for instance. This is just a way for us to set the target to whatever we want. And again, if you don't want it to always be the player, then you could have some other thing on here. You could actually probably even set this to like an Iai product or something. And so if you made the player also a product, then you could put any product in here, and you could potentially have enemies trying to target each other. So there's some options there. But I think this will be good enough. So we have our two non-virtual functions, so our awake and our set target. We got our variables up here. The most important one for most of this probably being the Iai Move, because that's going to allow for a sort of modular system. The rest of this stuff is mostly just sort of standard things: max health, movement speed, that sort of stuff. We'll talk more about this action in the very near future. And then we have our virtual functions that sort of do those little sort of things that we needed to do. So getting the movement, getting the attack, taking damage, destroying the game object, all of those little things. So before we go to before we talk about the action piece, that sort of action thing I have, does anyone have questions or want me to talk about a specific piece of this again? All right, so let me go back to the slides. And basically all this code that we just wrote is in here. There might be a couple differences from what I wrote, or the order might be slightly different. But variables, from the UML diagram, I didn't bother putting them all in here, and then sort of filling in all of these guys, and a few pop-ups as well. So get movement's going to be overridden by the concrete classes. The default implementation of get movement just does vector 2.0. And then a couple of these guys for this. So taking damage results in death. And then death is one of the interesting ones here. If we destroy the game object, remember our spawner. Our spawn manager has all the enemies in the list. If an enemy kills itself, because the death is called by the enemy itself. So if the enemy gets destroyed by itself, the spawn manager still has a reference to that enemy, which is now dead, which is now gone. So in our sort of CS speak, it would be null. The enemy object would be null, sitting in this all enemies array. We've never informed the spawn manager that an enemy died. An easy way around this would be to say that, all right, every single enemy needs to know about the spawn manager. So I could make a public or a protected spawn manager, call it SM or something, or lowercase spawn manager. And then down here, I could say, whenever right before you die, tell the spawn manager dot remove this. That would work, because this is me right before I die, and so I need to say I need to remove that enemy from the list. So I call remove enemy, and it'll get removed. That works. And this is probably, if you sort of ran into this problem out in the wild making your own games, this is probably the first thing that you think of. I need access to the spawn manager. But I want you to be careful here, because some sirens should sort of start going off. It may not initially, but as you, and this might be fine for a while, but as your program gets larger and larger, you're going to have all of these little entanglements. And this is that sort of, those sort of little sort of tangle things that I mentioned before. Why does the enemy need to know about the spawn manager? It should be understandable that spawn manager should know about the enemies. That hopefully sort of makes sense. That seems logical. But does the enemy really need to know about the thing that spawned it? It doesn't know about the factory, obviously, but does it need to know about the spawn manager? In my opinion, no. It shouldn't need to know about the spawn manager. Should it know about the game manager? Maybe you could write some other functions where maybe you use a game manager here instead. So we write a game manager, and we might have to come down here and say game manager dot get spawn manager or something. If we had a get spawn manager dot remove enemy this. You could do it this way as well. You could have sort of an intermediate thing. Use the game manager as sort of an intermediate, sort of communicate to the game manager that you need to be removed, either directly to the spawn manager or through another sort of function or something. But that also gets these little tendrils. Does the enemy need to know about the game manager? Maybe, but you have all of these interconnections, these little tendrils that sort of split out from your code, and obviously using stuff like using things like singletons and having to grab references to stuff like this all over the place is going to have code that's going to be tightly coupled. So I want to show you something that will make it so that enemy remains the way it was. Does not need to know anything about the game manager, doesn't need to know anything about the spawn manager, but we can still call this function. So that might seem kind of weird. How do I call that function without a reference to the spawn manager? That's the power of this action that I'm about to show you. So we're going to take this out of def, and we're going to get rid of this game manager here. And we're not going to add any variables. There's not going to be any extra variables added here. What we have now, we actually already have that capability with the stuff that I've written right now. And of course, it's based off of this kill enemy thing. So we have kill enemy. And in def, we're going to put in this line. The line looks kind of strange. There's a couple sort of strangeness things going on here. So this can be sort of tough to wrap your head around when you first see it. Actions in C# are, I think, the easiest way to sort of visualize this, and partially because I gave that lecture on array lists today to CS1. Array lists contain an array, a regular array, and then it does special stuff with that array behind the scenes. So actions are actually delegates and events, which you may not have heard of or used before, but it's sort of a similar concept. Actions are just delegates and events wrapped up in a class that does some special stuff. So you could actually do everything that we're going to do here without an action, but it would need a delegate and an event together. So actions sort of simplify it a little bit. If you want some more info on sort of delegates and events, I can show you what this needs to look like without an action, but with a delegates and an event. Delegates and events give you more flexibility, whereas actions are a little bit simpler to use. So you always get that sort of trade-off in computer science, of course. So actions are functions. That's what I want you to think of it. maybe not specifically are functions, but they contain functions. Think of it as an array list of functions. That might sound kind of weird, but if you messed around some with C or C++, an action is basically a function pointer. It just says, this is a function. Which function? I don't know. We haven't told it yet. We haven't told it what function it is. All actions have a single parameter. The parameter is what goes inside the angle brackets. And they have no return value. So kill enemy is actually, if I go into my code here, kill enemy is actually a container. A container for void function enemy E. Which function? I don't know. Who knows? That's not a question saying, does any of you know? It's just saying, who knows? I don't know. It's a function. And it's a container. It holds functions of the type void return and one parameter that takes an enemy. That's what I've done here. And I can't add any more. I can't add sort of more stuff here. And it's only allowed to be one. And this can be whatever I want, right? So I could have this be, a player as well. It doesn't matter. It just has to be a type. So for us, that is enemy. In order to call this unknown function, we need invoke. So way down here in our def function, I'm going to say kill enemy dot invoke. Then I need the type. I need what I'm sending this. What is the enemy that I'm sending? Because it needs one parameter. So I'm going to send it this. So I'm invoking this function, which sort of is technically the action, but I want you to think of it as a function. I'm invoking kill enemy, which is just a container for void function enemy E. So I'm going to call it. Whatever this function is, what is the function? I don't know, but I'm going to call it. There's one extra thing I have in here. What I currently put in code works fine. But I put this question mark here. Right now, kill enemy, the way we have it written in our code, kill enemy is just null. That's how it starts. It's null. It doesn't have anything in it. Essentially, it's a container for a function, but there's nothing there. If I try to invoke kill enemy when it is null, when there's no function there to call, it'll give me an error. So what I'm showing you is a nicety. The standard way to deal with that sort of null issue is to say if kill enemy is null or is not null, then do this call. This is sort of your standard way that you would do it. If kill enemy is not null, then do the invoke. But I don't need the if because I put the question mark. It does the same thing. So this null conditional will call what is after the dot if kill enemy is not null. Otherwise, it does nothing. So it's just a little nicety. I don't think Java has this. Java doesn't have the null conditional operator. So it's just a nicety. You don't have to use it. Just be aware of sort of what it does. It looks at kill enemy and first sees, is this null? If it's null, then it doesn't do anything else. If it's not null, so if there is something in there, if there is a function as part of this sort of container, then it will run invoke. And that's it. That's the only change we need to this. We don't need a reference to spawn manager. We don't need a reference to the list of enemies. We don't need any of that stuff. We just need the action. So we're sort of created a container for functions of this type, and we're calling those functions here. Now we go back, and I'm going to look at the slides here. I think I mentioned the null conditional. Yeah, so the null conditional operator here. Now we go back to the spawner, and here's where the magic happens. So back in my spawn waves, when I add the enemy to the list, I'm going to say E, that's my enemy, dot, remember, kill enemy, that action is public. So I'm going to say kill enemy, E dot kill enemy, plus equals remove enemy. This is the coolest part. This is my function container. What is this? It's a function that returns void and takes an enemy. So what I did was this kill enemy now contains this function. And so when I say invoke in enemy, it calls that function with this as the argument. And you don't just have to do it with one. Whenever you do this with an action, always use plus equals or minus equals. So this can contain, I keep calling it a container for functions. It doesn't have to just be one function. You can put as many functions as you want in here. So Nick, it's not only a C# thing. I don't think Java has it in the same way, but there are a lot of languages that can do this sort of thing. It's typically they go along with if you see a language has delegates and events, this is the sort of thing that delegates and events do. Action in C# just makes it a little easier to deal with, but delegates and events, if you see that actions that a language sort of has those two things, typically you use those together to get this exact same behavior. So that's the power here. And if you want to remove a method, let's say later on, some other time, we want to remove the method that would be called. We could do something like this as well. We could do the minus equals. So you can add methods to the list of functions in this kill enemy action, or you can remove them. So you can do whatever you want to. Just think of it kind of like an array, but it's an array of function calls. And to add and remove from the array, you just always use plus equals or minus equals. Typically, you don't want to use just equals, because if I have, let's say I have like 5 functions registered, that's the terminology here. If I have 5 functions registered to kill enemy, and later on I use just an equals, so I say something like this, then that completely overwrites the other 5 functions, and the other 5 functions are no longer registered. So it's best to use a plus equals or minus equals when you're doing this sort of registration stuff. To my knowledge, Andy, it should register them in order. I'm not 100% certain of that because I haven't sort of messed around with it, but I'm pretty sure they're done in order, the order that you register them. So the benefit here is this decoupling. I get the same exact sort of capability that I had by either giving the enemy a reference to game object or giving the enemy a reference to the spawn manager. I do the exact same thing, eventually call remove enemy, but I do it without enemy even knowing. And this is one of those things where it's not just for situations like this where you have to like remove something from an array that it otherwise wouldn't have access to, but basically anything. Imagine being able to register things like the sound you're going to play. Right? I might have the sound you're going to play when the enemy dies. I could have something like kill enemy, and I could have another function somewhere. It doesn't even have to be in the spawn manager, where I could be like, this is the play sound. Play sound. And as long as I have that function somewhere where I can do this sort of registration, it will call that function too. So it's a ton of different possibilities for using this action, this sort of registration system. The delegates and events, let me check the time here. So the delegates and events, let me see if I can remember off the top of my head exactly how this would go. The first thing that I would do if I was doing this with a delegate is I would create a public delegate, and this would, I'm Trying to remember all the exact syntaxes. So I don't use these as often as I use actions. I think it's going to be something like this. So I create the delegate as as what I want the signature to look like. So I could have a return type. With a regular delegate, you can have a return type and you can have as many arguments as you want. So that's a big difference between action. An action must be void, one argument. Whereas with a delegate, you have a bit more flexibility. But this delegate doesn't do it. We need the public, we need an event. And I think event comes from another, the public event. And I think this is where I would use the kill enemy right here, if I remember correctly. Again, I don't use this one nearly often. Oh yes, it's a public event remove, I think. Yeah. So this is the other syntax. This will work exactly the same way. I'm creating a delegate with the signature that I want, and then I'm creating an event of type remove called kill enemy. So it's exactly the same. They do exactly the same thing, except with delegates and events, you need these two lines. With an action, you just need this one. And an action is just a class that contains a delegate and an event. So it's kind of like the array list. An array list is a class that contains an array that can do special stuff with it. So that's the same sort of thing here. But everything else works the same. The invoke will work exactly the same with this delegate and event thing. So you don't need this special class to do this. You could just use these. So if a language has the sort of similar functionality in their delegate and event system, then you could do this sort of thing. And to me, if you don't remember anything else from working on this game, I think the action is probably the coolest thing, and will allow you to decouple your code in ways that you may not have thought possible before. And I think on the slides, I had one more thing in here. I have the set target that I call as well. So we have the registration of the we registered the concrete function to it, and then I have the set target. So let's go ahead and throw that into. I'm gonna call e.setTarget, and this will be GameManager.instance.getPlayer or just player. I don't remember what we did for it. So it'll be something like this. So we're grabbing the enemy, we're producing the enemy, adding it to the list, registering the remove enemy function, and then setting the target to the player. So that's my sort of when you spawn, this is all the stuff that we have to do to get it all set up. And I think the last stuff that I had for today, we might just do they're going to be really similar for now, the ranged enemy and the melee enemy. So we might just mostly copy and paste one to the other. So in the actual melee enemy and ranged enemy, I'm going to delete start and update. We're not going to need them. We will use awake, but we're not going to use the other two. And I'm going to make a couple of our variables here. So things like a private float called attack time. So kind of like the spawn time, but sort of an attack time sort of variant of that. And maybe a couple serialized fields as well. I think we'll have the game object. Actually, this one doesn't need that. It's the ranged enemy needs the game object for the projectile. So let's just have a float, and this will be time between attacks. And that'll actually, I don't need to set it. That'll just be something we'll set on the prefab itself. And then we're going to have the awake. This is going to have a weird keyword. I want to put new here. I'm going to explain why in a second. I want to call base.awake. And then, of course, anything else I want to add in there. New in this context is different from the new that you've seen in any of the news you've seen in Java or the news that we've used in C# so far. It makes it so that this one doesn't completely override the base version. I want to be able to call the base version, and I want this one to sort of be called first. So when we create a melee enemy, when we spawn a melee enemy, this new is called instead of the one from the base class. If I didn't put the new here, then I wouldn't actually be able to call base.awake. So it wouldn't work the same way. So this does actually need the new. You don't have to use this very often. It's just for this particular case, because we have an awake that is up here that is not protected, so we're not overriding it. We just need this one to be called so that we can call base.awake from here. I basically want this one to be called, and I want this one to be called, because I need this to be called because I have my functions in here. You wouldn't have to do this with a regular class because you'd have all the constructor stuff and the constructor chaining going on. But awake is not part of any sort of constructor operation. So there is no chaining. So by using this new, I'm sort of forcing a chaining here. I'm forcing us to use this one first, and then in here we're going to call the base awake. So that's what the new sort of allows here. That sort of allows us to do that chaining, but with not using constructors. We'll probably keep this get attack without anything in it so far. We'll just sort of leave it empty, but this is one of our overrides. So public override void get attack. And we can see that it just calls the base.get attack. We could probably take this out, even though the base get attack doesn't do anything, but we'll probably just delete it from here. And then we'll do another override for our get movement. I'm not going to call base.get movement, because remember what that does, it sets it to 0, sets the move amount to 0. But I am going to do base.move amount is going to equal Ai movement dot get movement. And we're going to use target dot transform and movement speed. So the enemy is going to have an Ai movement component, and we will use that Ai movement component to get what the movement needs to be to set move amount to then move towards the target, for instance. So when we add some of the AI stuff in, hopefully this will make a bit more sense for what it's doing. But just think of this as we're calling the AI to move the enemy, and we're going to get the movement that we actually need to do right here. So that when we call move, we're going to get movement and then do the actual movement on the rigid body. I'm going to copy this, and we're going to go to ranged enemy. And we're going to do the exact same thing, but we're going to have one more serialized field. And this is going to be a private game object, and this will be our projectile. And we'll do stuff with in the get attack, we'll do stuff with the spawn projectile. So we'll spawn the projectile in there. So we need that sort of extra piece. So this is our basic ranged enemy, our basic melee enemy. They're looking sort of mostly the same. Based on whatever AI movement component they have, that's how we get the movement. The rest of this, the awake, just gives us the rigid body and the health setting and the AI movement stuff. And that's basically it for these enemies. We'll mess around with the get attack, but the enemies are almost done. There's not a whole lot more to add. It's really, as long as we have an AI component, we can slap everything onto a game object and the enemy's ready to go. The spawn manager is basically set up. We can mess around with the factory if we want to determine how things spawn. We're really close. And I know it took a little bit of sort of a mostly coding day today, but hopefully this stuff was sort of relatively straightforward. If you go back through and look at some of the slides, I have all the pop-ups and stuff that sort of describe stuff a little bit more. But hopefully this was at least sort of somewhat interesting with sort of coding up the action and sort of getting a few of these things set up. That's basically all that I have for today. I think the rest of the slides here are just so here's the registering stuff. When it's invoked, it calls those functions. And then the enemy and the ranged enemy and the melee enemy. So New keyword ensures we don't call the base version only this version, and then we call the base from here, and then override and a few of those things, and the enemy as well. So we'll do some simple AI next time. We will code up something that implements Iai Move, and then we'll start adding this stuff to some actual game objects. And I'll try to figure out why my VS Code gives some weird errors and stuff. So that's it. I will see you guys on Thursday. Have a good rest of your day.
Thanks, Professor. Have a good one.